Um, so today's webinar is about customizing OpenNebula to fit your data center. So it's about the architecture of OpenNebula and how its modularity can be used to integrate OpenNebula with different components that may exist in your current data center. We can start by giving a brief introduction of what is OpenNebula. OpenNebula is basically a visualization manager that helps you turn your physical infrastructure into a virtualized infrastructure to run your services in a flexible way with all the advantages of cloud computing in terms of the optimal use of your computing resources. So the main characteristics of the OpenNebula software is that it's an open source Apache license software with a very unrestricted license. Basically, you can take the software and modify it and use it. You don't have even to tell us about that. It's also based on standards. The objective of this is to make it interoperable with other components. We'll see in a bit how to build applications on top of OpenNebula, and that's where the standards comes in handy to federate your cloud with another clouds or to make integrations with your favorite front end with OpenNebula and many other possibilities. And it's also adaptable, meaning it's a software that has been designed with a plugin approach with the integration in mind, right? So different actions are carried out by little scripts that can be easily custom made or even adapt to new situations, new scenarios, or new components in your data center. So what can you do with the OpenNebula software? Well, basically you can create clouds. There are different kinds of clouds depending on which is going to be the consumer of the cloud and also what resources does it use. So we can start about talking about the private clouds, which is basically turning your physical infrastructure into a cloud for internal consume for your internal users. You can also turn your physical infrastructure into a hybrid cloud with the components that OpenNebula ships to integrate with public clouds like Amazon EC2. This is a nice way to offload, outsource your computing needs in case you have to satisfy peak demands that cannot be satisfied with your current physical infrastructure. OpenNebula also gives you the ability to interface your cloud with public cloud interfaces like Amazon EC2 or OCCI. This makes it possible to offer your internal computing power to external users with the capacity of having some accounting to then even charge these external users for their computing usage. Okay, and it's a software that is ready for end users. There's a self-service portal that can be offered for end users consumption. It's a proven and thoroughly tested software, so it's robust for be used in production environments, and also it features an advanced user management. So you can basically limit the actions of users, group them, and basically manage your user base. Okay, so moving on to an overview of the OpenNebula architecture, we can see that everything is oriented to be a plugin, right? So we have the OpenNebula core sitting in the middle that is managing basically abstractions. So it's basically managing abstractions of your physical infrastructure and also of the virtual machines that are running, not only the virtual machines, but the components that make the virtual machine, like for instance, the images, the virtual networks, obviously the hypervisors that make that happen. So how does OpenNebula translate these abstractions into real operations on your worker nodes, on your hypervisors? Well, it uses other elements in your infrastructure. It basically uses drivers. The drivers are the programs that are in charge of translating these abstractions, these abstract operations into real operations. So we have different drivers for the different aspects of cloud management. So we have drivers for virtualization and monitoring, for networking, and for transfer and data store managing. We'll see them a bit more in detail afterwards. I also want to highlight that OpenNebula has different ways of being accessed to. So it features an XML RPC interface, which is the lowest level interface on OpenNebula. It basically gives the richer feature set of OpenNebula, and it can be programmed with basically any language. On top of that sits the OpenNebula Cloud API, what we call OCA, which are Ruby and Java bindings to this XML RPC interface with some goodies to make easier the life of the programmer at the time of managing pools of hosts or VMs or virtual networks and so on. So the design principles of the OpenNebula architecture are the modularity, it's achieved with this plugin approach. The lightness, the OpenNebula core is written in C++ and it's able to handle a huge number of abstractions without big performance loss. And also the openness of the architecture. So it's not just a matter of the license of the code, but also a matter of how easy it is to hack into it, so to speak. Okay, so this webinar is going to be shaped in roughly three big blocks. The first one can be seen as the how OpenNebula can integrate with other components. So how these drivers can be tailored or even make up from scratch to interface with different kind of components, like different kind of hypervisors or different kinds of authorization mechanisms. So that would be like the first part. And the second part will speak a bit about how to integrate, how to build on top of OpenNebula, how you can build automated tasks that take care of any aspect you want of your virtualized infrastructure. Also, how can you offer the features of this newly created cloud to other users through different front ends, and how can you basically build applications on top of OpenNebula. And there's another third block, which will be about customizing images to be used in an OpenNebula cloud. What do you have to do with your guest OS so they are ready for an OpenNebula cloud? Okay, so let's begin with how to interact with your existing components, how to tailor OpenNebula to fit your specific needs. So we'll be talking basically about drivers. Drivers are small scripts that are custom made for each action, depending on the category they are on. They can be virtualization drivers, which basically speaks and operates directly to your infrastructure hypervisors. There's also monitoring scripts that will be periodically polling your hosts and your virtual machines in order to get information about their use. There's also another set of drivers that can handle images in data stores. That the data store drivers are also the transfer drivers that basically are gonna get these images from the data store into your worker node. So yeah, basically what OpenNebula does with this is interface different image servers, so to speak, being that iSCSI servers or NFS servers, and that's what we call the data stores. And once the images are there, they have to travel to the end hypervisor node, and that's actions are carried out by the transfer manager scripts. There's another couple of driver category, that the network drivers and the authorization drivers. The network drivers take care of the physical infrastructure and networking, so the virtual networks can be built on top of them, and also the authorization drivers, which are the ones that manage the permissions that your user have on your physical and virtual resources. The main point of having independent drivers is to be able to coexist different drivers in heterogeneous environments, also make them easy to adapt and easy to create new ones. One of the best outcomes of this architecture is the ability to create or modify drivers and being able to keep those changes across different OpenNebula versions. We tend to be careful on what APIs, internal APIs, we change, and we tend to not to change it that much. So your newly curated or adapted drivers can live across different OpenNebula versions without you having to merge your code into the new one. Okay, so let's start with the virtualization and monitoring drivers. The virtualization drivers are the ones that translate the OpenNebula virtual machine lifecycle management into specific hypervisor operations. There's a number of drivers out of the box for different hypervisors, like, for instance, KVM, Xen, or VMware SSX. And there's also hybrid drivers, which are drivers that are able to interface with a public cloud offering. Like, for instance, we have out-of-the-box drivers for Amazon EC2. Okay, there's also community contributions. These are third-party contributions to the OpenNebula ecosystem. They are not supported by the OpenNebula team, but they are still quality drivers that you can use to interface different hypervisors, like, for instance, Hyper-V or Oracle VM, Xen Cloud Platform, OpenVSet, and there's also a driver for Delta Cloud, which are basically a really useful driver to interface with different hypervisor APIs or even public clouds. Okay, that will be the virtualization drivers. We also have in this category the monitoring drivers, which are the ones that gather information of the physical host and the hypervisor status. Also, these monitoring probes are small scripts that can be easily tailored or easily added to your system. We'll see. Can go now to see an example of a virtualization driver. Okay, so let's take a look at the Xen hypervisor drivers. As you can see here, these are small scripts that handle the operations that OpenNebula core request from a virtualization driver. So basically, we have here actions to make a deploy of a virtual machine, to make a monitoring of a virtual machine, to cancel the virtual machine, to reboot the virtual machine, restore, shut down, and save. So let's take a closer look to the migrate, for instance. The migrate script is as simple as this. It basically receives a couple of parameters given by the OpenNebula core. Basically, the deploy ID of the virtual machine and the destination host. And with just a XM migrate order, the virtual machine, the hypervisor knows that it has to migrate the virtual machine from one host to another. So as you can see here, this script is quite simple. It's very easy to adapt to new hypervisors or even new versions of Sheng, given the case that they are not backwards compatible anymore. So changing this simple bash script in your OpenNebula deployment will give you extra functionality, or maybe functionality that is more specific to your needs than the one that it's offered in the out-of-the-box OpenNebula deployment. Okay, so moving on into handling the images that conform a virtual machine, we have data store and transfer drivers. As I briefly told before, the data store drivers are the ones that are in charge of taking an image of a virtual machine that you provide that is sitting in your desktop, or maybe in an image server that offers it through HTTP somewhere. The data store driver is the one that makes the cloning or the copy of that image into the data store. So once it's in the data store, the OpenNebula Cloud is able to use that image to create new virtual machines. Aside from the data store drivers, we have the transfer drivers. These drivers are the one in charge of moving the image from the data store to the particular host that has been chosen to run a particular VM. Okay, so again, these drivers are also made with a plugin approach. So for instance, in the transfer drivers, you have small scripts like the copy script or the clone script that is basically going to take the virtual machine, and depending on your particular infrastructure deployment, it can move the image through a simple copy if it's everything shared by NFS. It can add the image to, for instance, BMFS, VMware data store, or add it to, say, I don't know, a central repository through SSH. Okay, so these drivers are also made by small shell scripts that can be easily hacked. They tend to be a bit more complex than the virtualization drivers because they have to deal with more generalities. But at the end of the day, they are pretty simple to hack if you have a bit of experience on shell scripting, which is what more of the drivers are written in. So we have here a set of drivers that are shipped in the out-of-the-box OpenNebula distribution. So you see you have drivers for different protocols, image transfer protocols. And there's also the community contributions, like, for instance, a very interesting set of drivers for working with the OpenStack Swift storage solution. Also some drivers to do parallel SCP copies in kind of a BitTorrent kind of fashion. It's also drivers for the CDMA standard. Also drivers for the Stratus Lab marketplace, and drivers for the Moose file system. Okay, moving to the networking drivers. The networking drivers are in charge of managing the network configuration in the physical hosts. So they are able to add things like automatic bridge creation or firewall rules to your virtual machine. So you have the chance to tell OpenNebula, please bring me up a virtual machine, but I want all of the ports closed, just maybe the 80 open to act as a web server front end. Offers also network isolation through some out-of-the-box drivers like the EVTables driver. There's also interface to the Open vSwitch networking software, and also 802.1q drivers to be able to handle VLANs between your virtual networks. Okay, again, these networking drivers are easy to hack into scripts, also written in shell script, most of them. So changes can be easily moved between OpenNebula versions. Moving on to the authorization drivers. These are drivers that interact also with your infrastructure, but they are not meant to transfer images or build virtual machines or things like that. They are meant to control the users you want to access your cloud, or what actions these users are meant to be able to do. The plugin approach in the authorization drivers has the objective of making OpenNebula more easily to integrate in your existing data center. For instance, you may have your user base handled by an Active Directory server, so there's plugins shipped with out of the box OpenNebula that are able to interface with the Active Directory. So if you have a user in the Active Directory and you kind of enable this plugin, then all the users automatically will have access to your OpenNebula cloud. There's also more out-of-the-box drivers for authorization, like for instance the X509 certificates, LDAP drivers, and there are drivers as well to manage quotas. So this is good for capping the users, for not letting them to consume all the resources that conform your cloud. And there's also drivers that manage the ACLs. So you can fine-grain tailor your scripts to make, for instance, a group of OpenNebula users to not be able to do certain action on a specific host. I mean, OpenNebula tries to handle all of that internally, but there are special cases where you may want to develop your own ACLs. So in this way, you don't have to really get into the insides of OpenNebula to move some C++ lines of code around or add your own to see if everything works. But you can just simply hack an external shell script and get the same functionality. Okay, so moving to the second block, let's talk about how to build applications on top of OpenNebula. So basically, OpenNebula offers this XML RPC very simple and fast API that works in any language, and then some bindings, some high-level bindings made in Ruby and Java, and there's even some Python bindings for it. So you can, with this, build your own scripts, your own automations of daily tasks, for instance, and be able to interact with OpenNebula in a simple Ruby script, much easier than just making some program to directly talk with the XML RPC. The OpenNebula Cloud API comes with it, as I said before, to handle pools and to extract information for certain objects. So it's kind of handy to build applications on top of it. As an example of an application built on top of the OpenNebula Cloud API, we find the OpenNebula Sandstone, which is a web server, a web interface, sorry, to your OpenNebula Cloud. Okay, so this is a simple example of a script that can automate a daily task, like for instance, shut down all my virtual machines. Can quickly go through it. It basically defines the endpoint of the OpenNebula Cloud, which is basically the point of the XML RPC port, where OpenNebula listens for new commands. And also the credentials, which are basically your username and password to access your OpenNebula Cloud. So in Ruby, once you successfully import the OpenNebula module, you're able to create a new client, for instance, which then will be used to perform other operations. Here we can see that we are requesting a virtual machine pool. So this will be all the virtual machines that I have access to. So I pass it the client and also the flag. So I want my virtual machines, not everyone else's. Obviously, this operation, like get me all the virtual machines in the cloud, can only succeed if you have the right permissions, like if you are one admin, which is basically the root of your OpenNebula cloud. Once we have the object virtual machine pool, we can query for it. So what this is going to do is going to fill the pool with information, fresh information taken from the OpenNebula core. And then we can simply iterate through each virtual machine in this virtual machine pool and issue the shutdown order. So in this way, we're having a single script, really, I would say, handy way of shutting down all the machines or programming some other daily tasks that maybe they are not covered by the OpenNebula command line interface. Okay, this is a screenshot of Sandstone with the dashboard showing the accounting information from on the real-time monitoring from your physical infrastructure. I bring this up because I want to also comment that Sandstone is kind of modular. So say you are extending OpenNebula for a new functionality by creating a new set of drivers for some different component, and you want to offer that functionality through Sandstone. If it's not covered by any of the tabs that are out of the box, you have the possibility to create new tabs in an easy way. It's also a plugin approach where you have means to create a new tab with certain layout to display some information or to trigger some actions you may have extended OpenNebula with. Okay, so what else can you build on top of OpenNebula? Well, there's a number of cloud servers to implement different public cloud APIs, like for instance the OCCI server, which exposes OGF standard for virtual machine storage and networking management. In this way, you can also build your programs with OCCI in mind. Instead of using the OpenNebula Cloud API, maybe you want to build an OCCI, your program with an OCCI interface. Or even better, you may have some programs that work with an OCCI interface, so you can plug it into an OpenNebula Cloud. This is also true for Amazon EC2, where a subset of the EC2 query API is implemented in a EC2 compatible service. So you can plug any application you may have developed for Amazon EC2 Cloud, then you can plug it into your local OpenNebula Cloud and cut some costs from Amazon. It's interesting to see how other tools that were thought to interact with Amazon can be used to interact with an OpenNebula Cloud, like for instance, Hybrid Fox or the EUCA tools. On top of the OCCI, we have shipped out of the box with OpenNebula, the OpenNebula self-service, which is basically a web interface designed for public end users. So you can see Sandstone like a kind of internal and also administrators interface, and the self-service for more externally detached users. In the field of the community contributions, we can find also another implementation of the OCCI interface, which is more up-to-date than the one that ships out of the box with OpenNebula. There's also tools that can be made interact with Chef or Puppet. and some other ecosystem of public cloud interfaces to interact with your OpenNebula cloud. Okay, so moving to the last block of the webinar, we're going to talk a bit about how to build applications for OpenNebula. So how to craft your images, the images that conform a virtual machine, how to tailor them so they can be consumed by our OpenNebula cloud. The point here is to make them compatible with the marketplace. Marketplace, the OpenNebula marketplace is a catalog of third-party virtual appliances ready to run in OpenNebula clouds. This marketplace is a public service offered by C12E, and it's fully integrated with OpenNebula. Samsung comes with a tab that displays the available third-party appliances, and with a simple click, you can download them to your OpenNebula cloud and register into your data store and make it available for users of your cloud to build virtual machines with it. C12V is also releasing in a few days a new component called App Market, which basically will let you people with an active OpenNebula Pro subscription to build a in-house marketplace. And this way you can federate different instances of OpenNebula through a common repository for virtual machine images. Okay, so what do I need to do to build a VM that is compatible with the marketplace? There's basically two aspects to it. One of them is put in place the OpenNebula contextualization script that kicks on at the time of booting the virtual machine and prepares the networking and also the custom information you may want to pass to your virtual machine. It takes care of that, and it's essential to if you are not using things like a DHCP server. It also disables the UDEF network rule that will basically give you a new MAC address on each boot, and this will prevent OpenNebula to be able to give the right IP to your virtual machine. We ship these two actions in a contextualization package. This can be seen kind of an equivalent to the VMware tool, so it basically prepares your guest OS to be used in a OpenNebula cloud. There will be two new additions as well, aside from the App Market, to active OpenNebula Pro subscription holders. That's going to be called the App Flow App M. That will be simplify and optimize the execution of complex applications on your OpenNebula cloud. So it will basically let you handle a service or an application, which is basically a set of virtual machines that interact with each other, conforming a service, like for instance a web server or something more related to a batch job processing. Well, anyway, we'll let you handle a group of virtual machines interconnected. It will let you do some auto-scaling, for instance. It will manage a set of VMs rather than just one. The other component, the add-env, will let you customize your virtual machine once before it gets run. So you can basically in the first release, you will be able to use chef recipes, for instance, to install automatically software in your virtual machine once it's booted. Okay, so this is a screenshot of the marketplace. You can navigate to marketplace.c12g.com and you will see this very same screen with a listing of different guest OS, different appliances that you can download to be used in your OpenNebula cloud. Okay, so summarizing, what OpenNebula offers to integrate in your data center. So what does it have to make it easily integrated with existing components that you may not want to get rid of in your data center. So the flexible architecture is the strongest point. It's not just the core that is flexible, but also the drivers, the APIs, and the web interface. It's based on standards, so it can be easily integrated with other cloud solutions, or other cloud solutions can be plugged into OpenNebula if they support the same standard. As we were saying, everything is plugin oriented. There are small independent actions that are easily replaceable and also adaptable. And importantly, the easy updates. You can maintain your changes across OpenNebula versions without having to worry too much about merging your changes with the new change log of OpenNebula. And it's also been designed to be integrated on both phases. The upper layers have different interfaces. The underlying layers is plugin oriented, so it can be extended both on top and from down the underlying infrastructure. Okay, and this is more or less the contents of the webinar today. Now, if you have any question, please feel free to ask it in the chat or raising your hands. I will open your mic. If you have any problems integrating OpenNebula in your data center, you can contact us at services@c12g.com, and we'll be happy to review your case and offer you some advice. Oh, okay. Sorry, Yang. Hi, hello. Jeff? Okay. False alarm, maybe. So Jeff is asking if I can share the slides. Certainly, yes. These slides will be available in the webinar's webpage. I think we can. So if you go to the c12g.com page, you can go to resources, webinars, and this webinar will be archived into this webinar archive. You can have here. You can review the video, the recording of this webinar, and also you can download the slides. Okay, so if there's no more questions, thank you everyone for attending the webinar. I'll be available through mail at tinova@opennebula.org in case you want to drop me some lines for any doubts that might arise afterwards. And all in all, thanks for coming, and see you in the next webinar. Bye-bye.